Number 1. Which of the following best illustrates an application of Newton's first law, also called the law of inertia? A. A passenger not wearing a seatbelt is ejected from an automobile during a severe crash. B. Wine glasses remain on a table when a slick tablecloth is yanked out from underneath them. C. An ice hockey puck continues sliding across the relatively frictionless ice until it comes into contact with a wall or a player's stick. D. All of these are examples of Newton's first law. Number 2. While in outer space, a rocket engine is able to produce thrust on a spacecraft. Identify the correct action-reaction pair which allows the spacecraft to propel itself forward. F. Rocket engine spacecraft. G. Rocket engine nozzle exhaust gases. H. Exhaust gases and air behind the spacecraft. J. Exhaust gases and the ground. Number 3. According to Newton's first law, the law of inertia, when you lean back against the chair pushes back against your back. B. When you kick a soccer ball, the ball pushes back against your foot. C. When you push a shopping cart that is still, it rolls forward. D. When you hit a baseball, the bat can vibrate and hurt your hands. Number 4. A student fills identical cylindrical jars with different materials: sand, gravel, marbles, water, cooking oil, chocolate syrup, honey, chicken noodle soup. The student has a 1 meter long ramp, a meter stick, a stopwatch, and a protractor. Which of the following questions could he be attempting to answer? F. Which medium carried the best electrical properties? G. Which medium has the highest melting point? H. Which medium absorbs the most light? Or J. Which medium will accelerate most rapidly as it rolls down the ramp? Number 5. Mountains in the Himalayas are increasing in elevation due to A. Seafloor spreading, B. The action of earthquakes, C. Colliding tectonic plates, or D. Transform faulting of a tectonic plate. Number 6. Mrs. Fields showed a video to her class. In the video, a balloon was warmed in front of a small heater. When the warmed balloon was released, it floated toward the cooler ceiling. Then it slowly drifted back down where it was warmed, rose up, and drifted down again. This model represents which of the following concepts? F. Thermocline, G. Convection, H. Thermoregulation, or J. Conduction. Number 7. Which feature of Earth will be most difficult to demonstrate using a globe model of the Earth? A. Angle of Earth's axis. B. Shift of Earth's continents. C. Location of Earth's equator, or D. Direction of Earth's rotation. 8. Which of the following models would be best to show the interaction of continental plates? F. Stacking 2 pieces of clay. G. Rolling a piece of clay into a ball. H. Pushing 2 blocks of clay together. Or J. Pouring water over a dry piece of clay. Number 9. What is one condition that is necessary for a hurricane to form? A. Warm ocean water. B. A strong cold front. C. Cold ocean water. Or D. A strong warm front. Number 10. The direction that an ocean current travels can be altered by the movement of the Earth's rotation on its axis. This is known as the F. Revolution theory, G. Water cycle, H. Climate, or J. Coriolis effect. Number 11, an air mass that is moving from the North Pole towards the equator would be turned blank because of the spinning of Earth on its axis. A, to the east, B, to the west, C, back towards the north, or D, to the nearest body of water. Number 12. A section of a topographic map is shown below. What is the difference in elevation in meters between point X and point Y on the map? Record your answer and fill in the bubbles on your answer document. Be sure to use the correct place value. Number 13. Which point on the map would be the flattest area? Number 14. The topographic map shows a canyon. At which point does the canyon have the greatest change in elevation? Number 15. The convergent boundary is formed when two tectonic plates meet and push against each other. What type of landform would occur at this type of boundary? A, canyon, B, coastline, C, mountain, or D, plains. Number 16. Students are demonstrating plate tectonic motion by moving graham crackers over icing. If the students were to pull 2 graham crackers apart, revealing the icing underneath, which landform have they represented, and at which location on the diagram would this be found? F, trenches at location 3, G, subduction zones at location 4, H, ocean basin volcanoes at location 2, or G, fault lines at location 3. Number 17. The thick black lines on the map below show the locations of mid-ocean ridges. Which geological feature is most likely to form at a mid-ocean ridge? A, peninsula, B, volcano, C, delta, or D, plateau. Excuse me. Number 18. The model below shows 2 continental plates. The folded mountains in this model form at which type of plate boundary? F, transform boundary, G, divergent boundary, H, subduction boundary, or J, convergent boundary. Number 19. When the sea floor spreads apart, volcanoes such as these along the Ring of Fire and ridges such as the Mid-Atlantic Ridge are formed because A, sediments are deposited where the sea floor spreads, causing volcanoes. B, as the plates pull apart, magma moves to the surface, building ridges. C, ocean water erodes the weak spots on tectonic plates, building ridges. Or D, cold ocean water causes fissures that weaken the rocks, causing ridges. 20. Islands in the Pacific Ocean, such as Hawaii, form because F, as the sea floor spreads apart, sediments gather due to ocean currents. G, the pressure of the water causes magma to rise to the surface. H, as the sea floor spreads apart, magma rushes to the surface. Or J, the tectonic plates are pushed together, forming underwater mountains. 21. A convergent boundary is formed when 2 tectonic plates meet and push against each other. What type of landform would occur at this type of boundary? A, canyon, B, coastline, C, mountain, D, plains. The term seafloor spreading is best used to describe F, the submergence of the Pacific plate beneath the Northern American plate. G, the rapid drop-off between the continental shelf and the abyssal plain. H, a tsunami effect associated with an eruption of an underwater volcano. Or J, magma upwelling and lateral expansion along the Mid-Atlantic Ridge. Number 23. The Pangea theory of a single massive landmass that may have broken apart into what we associate with modern land masses and major continents was first supported by what significant evidence? A, similar climate and weather patterns on continents very remote from each other. B. Fossil evidence of identical species on continental coastal regions and continents separated by oceans. C. Extensive volcanoes present in the Pacific Rim of Fire on both sides of the Pacific Ocean. D. Basalt mineral formations found on the west coast of Africa and on the east coast of South America. 24. Which is best evidence that continents that are now separated were once joined? F. Continents that were once joined have similar climates. G. Identical plant and animal fossils are found on continents that are now separated. H. The cultures of the people on the separated continents have similar languages. J. The migratory patterns of wildlife on separated continents are similar. 25. Jack placed a coin on a card on top of a glass. He quickly pushed the card and the coin fell into the glass. Which statement below explains his result? A. Force is equal to mass times acceleration. B. A body in motion tends to stay in motion, or a body at rest tends to stay at rest unless acted on by an outside force. C. Momentum equals mass times velocity. Or D. For every action there is an equal and opposite reaction. 26. The tendency of an object to resist changes in its motion is related to one of Newton's laws. It is called F. Acceleration, G. Force, H. Inertia, or J. Work. 27. 4 students race toy cars on a track. The mass and the acceleration of each car is recorded in the table below. Which toy had the greatest applied force? 28. 2 cars with different masses travel at the same speed down a hill toward a stop sign. What will happen when both cars apply the brakes at the same time to stop? F. The car with the smaller mass will require less force to stop than the car with the larger mass. G. The car with the larger mass will maintain its velocity while traveling down the hill. H. The car with the smaller mass will take longer to stop than the car with the larger mass. J. The car with the larger mass will have less inertia than the car with the smaller mass. 29. The picture above illustrates the horizontal forces acting on the car. The car's engine force pushes forward, while friction between the tires and the road, along with the wind resistance, drag at the car in the backwards direction. Which of the following must be true about these forces if the car is driving forward on a level road at a constant speed of 45 miles per hour? A. The force of the engine forward must be greater than the force of the gravity acting on the car. B. The force of the engine forward must be greater than the combined forces of friction backwards. C. The force of the engine forward must be less than the combined forces of friction backward. Or D. The force of the engine forward must be equal to the combined forces of the friction backward. Number 30. When the 2 tectonic plates collide, the new mountain ranges can be formed as rock in the Earth's crust is thrust upward. Usually this action involves one plate being pushed underneath another plate, as shown in the diagram below. Which of Newton's laws best describe why the edge of the right-hand plate forms mountains while the left-hand plate is submerged beneath the right in the picture? F. Law of inertia, first law. G. Law of acceleration, second law. H. Action-reaction, third law. Or J. Law of universal gravitation, fourth law.